You're listening to the Reversing Climate Change podcast by the team at Nori, the carbon removal marketplace. This is a show about the innovators and entrepreneurs developing solutions to climate change.
Hello and welcome to the Reversing Climate Change podcast. I'm Ross Kenyon here with Christophe Jaspe. We woke up extra early this morning because we are talking to fellows both in our country, but also in far away Russia. And it was the only way to make the time zones work. We haven't done remote episodes yet because we prefer to be in person, but we thought it would be extremely unlikely, nay, impossible to actually get our guests in the same room at the same time, despite the fact that their story is perhaps best told together. I don't even know where to start with this, Christophe. We've been hearing about Pleistocene Park for a long time. One of our advisors is obsessed with it or has been talking about it for a very long time. We read about it more in the book Drawdown. I read Woolly, The True Story of the Quest to Revive History's Most Iconic Extinct Creature by Ben Mesrich. And so we have with us today Nikita Zimov and George Church. Christophe, I will lead it to you to introduce them more.
I'm pinching myself because we're delighted to have both of them on here. I guess we'll start with introducing them, Ross. That's usually how we do these podcasts, right?
I believe so, yes. That is an appropriate way to begin.
Well, so we'll start with George. He's an American geneticist, molecular engineer, and chemist, and he is currently at the Harvard Medical School. He's really known for a lot of his work in gene sequencing, genome sequencing, and then we'll pass it over to Nikita Zimov, who is the director of Pleistocene Park, not to be confused with Jurassic Park, but maybe there are some similarities.
I think in the naming convention there, I think that was intentional. Maybe we'll find out.
It's quite possible. But George, good morning. I think it's still morning over there in Boston. If you'd like to start out with, well, your career is quite long and illustrious, so we don't need to go through all of the points on your resume. But really, if you could connect the dots for us a little bit as to what led you to where you're here today on this podcast talking with Nikita?
Yeah, well, like many young people, I was fascinated with megafauna when I was young, especially mammoths. And I was inspired by the World's Fair in 64. And then soon after we invented next generation sequencing around 2003, it was applied to ancient DNA, which was having trouble sequencing up to that point. And now there are many ancient species that were done, and journalists asked whether we could synthesize as well as sequence. Could we test the ideas coming out of the sequence? And with a little reflection, I thought that might not only be theoretically possible, but could be quite interesting. And then I started reading about which species would be best, and it just kept coming back to mammoth as being the most interesting, especially as I read more and more from the Zimov team about the possible ecological implications for a herbivore that could knock down trees and enhance the grass. So it just became quite compelling. And ever since, we've been working on better ways of doing genome editing so that we can do with elephants what we've essentially done with pigs, which is doing multiple edits to enhance their ability to cope or deal with certain new functional needs.
So for the layman out there, what does genome sequencing even mean? And what has happened that has made it possible to do some of the things that you're working on today?
Well, being able to read and write DNA has evolved extremely quickly. Our lab has contributed to many of the methods for both reading and writing DNA or genomes, such that they're about 10 million times less expensive now for a variety of applications, ancient DNA just being one of them. And what reading means is that you take usually pure DNA, although it can be broken up. Typically, ancient DNA is broken up, and you can read it A, C's, G's, and T's into the computer. Most mammals, like humans and mammoths, have 2 copies of 3 billion base pairs of DNA in each of their cells. And so we want to read that accurately into the computer, and then we take it from the computer and write it back out without the breaks. So it's broken when we find it, but then we want to rewrite it in an unbroken way. And one way of doing that is literally chemically synthesizing it, and the other way is editing a closely related species, sort of iteratively editing it to the point that it has changed into a hybrid of an ancient and a modern species.
Thank you for that. And Nikita, how about for you? What was your path to get to where you are today?
Hey, well, my story wasn't that long and sophisticated. I grew up in a family where creating Pleistocene Park was a thing and was the main activity. So the park was founded back in 90s, and idea came to my father's head back in 80s. And so his name is Sergei Zimov, and he is the one who started this experiment and the whole idea of restoration of grassland ecosystems in the Arctic. And so I basically grew up, got high education, and came back to the family business.
Yeah, that's quite. I think you might be the only person on Earth where that's the family business. Very unique. What is the vision for Pleistocene Park? What do you imagine happening? Why do you think it's important and worth continuing the family trade?
So very briefly, just 15,000 years ago, the entire Arctic looked totally different than it looks now. So there were millions of herbivores roaming in this landscape, and it was mostly grass-dominated landscape. And pretty much, I think the closest analog would be Serengeti. So most of the planet looked like a Serengeti, including the Arctic. And then when Ice Age ended, first humans came to the land and destroyed this ecosystem. So they dropped number of animals substantially, driving some animals extinct. And unfortunately, in the Arctic, grasses cannot compete against other vegetation like mosses, shrubs, and trees without help of animals. So animals actually allow grasses to grow, so they trample down their enemies and they allow grasses to dominate. Without animals, very quickly, after the number of animals went down, grasses were replaced by the mosses, shrubs, and trees, which are very low productive vegetation. And modern ecosystems in the Arctic, it's considered as a wilderness. However, this is actually all invasive plants out there, and they currently does not give any benefits neither to humans nor to animals. So you can drive through entire Siberia and not see even a single big herbivore. And our idea is to reverse the whole system back. So we want to bring animals which either lived in this place or can live there now, or maybe with the help of George, we can eventually get animals which used to live there now but are now absent on the planet, and adapt them to the new place, help them around, and allow them to promote grass growth. So when you introduce animals, they trample down the mosses and shrubs, they eat bark of the trees, mammals actually knock down trees, and we in the park see that the grasses start to grow better, and eventually we want to create ecosystem which will be self-sustainable, full of herbivores, full of predators, which will be able to exist on their own. First of all, it will dramatically increase the richness of the ecosystem, of the modern nature. And also, most importantly, these ecosystems allow to mitigate climate change, at least to some extent. So these grasslands in the Arctic are way more beneficial in terms of cooling the climate compared with the modern ecosystems we have there now.
I think when people think about reversing climate change, hey, that's the name of the show. The Ron Howard. Why would they prefer grassland to trees? I think people normally think that trees have a lot more potential than grassland. Granted, this would be an error, but why would grasslands in the Arctic be so valuable?
So the logic, the most common logic, is actually coming mostly from the tropical forests, which is definitely, I think it's true, the statement for the tropical forest. It's already less true or debatable in the temperate climate, and in the Arctic, it's just not working this way. So just to give you some brief numbers, on each square meter of territory in the Arctic, on average, above ground vegetation is only 2 kilograms per square meter. So vegetation in the Arctic is anyway very sparse and very poor, and you cannot store much of the carbon. So basically, you cannot absorb much CO2 from the atmosphere. So reduce the CO2 concentration by much, because surface and above ground vegetation cannot store much. However, soil in the Arctic is totally different story. The decomposition in the soil is very low, and potentially you can have up to 100 kilograms of carbon on each square meter under the ground in the top meter. So just 50 times different. In the tropics, vice versa. You can have huge trees which will store lots of carbon in it, However, soil decomposition in soil is very high, and you cannot store as much carbon as you would be in the above ground vegetation. So if in the tropics people say that we need to protect rainforest, I would say nothing against it. This will allow to have more, having rainforest in the tropics will allow to have more carbon in the system. In the Arctic, it's the other way around. The grasses forming a very deep root system and pumping the CO2 from the atmosphere down to the very cold environment where it's protected from decomposition and protected from fires. So that's a continuous sink of carbon. Additionally, if you look at the forest and if you look at the grassland, you will see that grasses are slightly lighter than forest. So it's called albedo effect. So the lighter the surface, the more energy, sun energy, it's reflecting back to space without converting it into the warming temperature. And especially in the Arctic, the difference is, well, in the summer, it's the shades of green. It's not that pronounced. But in the spring, April, May, right now. So right now in Chersky, where I just came from 2 days ago, there is enormous amounts of sun. And all the grasslands in the park are still covered with snow. So they're entirely white. And they're reflecting all the sun energy back to space. And all the shrublands and large trees, they don't have any leaves or needles, and they have their dark stems, which are absorbing enormous amount of sun heat. And the snow is melting around trees just faster. So it's a quite substantial effect. And third, quite important, and I think most beloved by media, idea is that just in our, relatively little state of Yakutia, so just one state of Russia, there is more carbon in the permafrost, stored in the permafrost, in the forms of tiny little roots which accumulate maybe 30,000 years ago, 40,000 years ago. So biomass of these roots is more than a biomass of all above ground vegetation of the planet. So it's a huge source of carbon, which have been stored there for tens of thousands of years and been intact. But now with the climate change, the temperature of air is rising, and so do the temperature of permafrost. And already last year, there was 3 very warm and snowy years, and in some places, permafrost already started to degrade in our region. And when and if it will happen on a large scale, it will be one of the largest sources of greenhouse gas to the atmosphere. And it will be a very substantial increase in, it will very substantially accelerate the climate change in their own direction.
So I'm really glad that you actually brought up permafrost, because that is a big concern. I mean, I see videos at times where someone's standing over a lake and they just light a candle or a match and literally it catches on fire because you have this very intense gas just bubbling out of the lakes. And a big part of that, as you say, is the decomposition. And so just to get this straight, what we're talking about is large mammals moving over the grasslands, eating the grasslands, which is on the permafrost itself and actually contributing to restoring the carbon into the soils in a way that counteracts some of this effect. Is that correct?
No, there is 2. So if you look at our ground, so the top meter is something that's thawing every year. So that's somewhere the roots are growing, and basically below the meter is a soil which never thawed, at least in the last, hundreds of thousands of years. And out there, this carbon is stored. And first of all, we can get more into the top meter with this ecosystem. So the thing I was explaining you originally. And secondly, all this, we have this 40-meter thick soil, which store this enormous, almost some places over a ton of carbon on each square meter. So the concentration of carbon there is higher than anywhere else on the planet. And with the climate change, it's getting melting, and these lakes are forming, and the methane is produced. So when permafrost is degrading, microbes quickly convert these roots into greenhouse gases, methane or CO2. And if there is a way to prevent permafrost from degrading, that's a very good and urgent thing to do.
Got it. And right before we started this podcast, you started describing let's just, for lack of a better word, call it logistical challenges of getting different megafauna up to this region. So why do we need megafauna up in this area? And I guess just like anecdotally, how is it going? What's it like with the different bison and the different animals?
Well, so first of all, the main that animals allow grasses to grow. So basically, animals need grass to have enough food, but in contrary, grasses need animals to compete with other vegetation. So that's the main thing. It's chicken and egg problem. So what we are trying to do, we are artificially maintaining those animals in the park, allow them to have this grazing effect. Secondly, the thing I didn't explain before, but to protect permafrost, we need to trample down the snow in the winter, which would allow substantially cool the permafrost during the winter time and drop the overall temperature. And animals looking at the grasslands, they go and graze all year round, and they trample down the snow, and they allow substantial cooling of permafrost. So that's why we need big herbivores. The higher the variety, the more effective the ecosystem. So the more animals we can bring, the better. And yes, the challenges if transporting animals is actually quite big. So tomorrow I'm flying to the western part of Russia, and in a week from that time, we'll get to St. Petersburg and drive to Denmark, where we will load 12 bison on a truck, and then head out all the way to the Pleistocene Park, which would probably take us more than a month, and it's about 10,000 miles by car, by trucks and boats and barges. So that's going to be quite intense.
That's an adventure. I've also seen updates online of this isn't the first time you've tried to get megafauna out to the far reaches of Siberia. It seems like a regular adventure of yours.
Unfortunately, yes, it is a regular adventure. Very often when you don't have enough resources or finances to do it the proper way, you are forced to do it adventurous ways. So I have lots of adventures in my life.
Why don't you just get George? Why don't you just cook him up some woolly mammoth? What's the holdup over there?
Well, I think we need both. We need a diverse ecosystem. And obviously what we're doing is not been done before, so we don't know exactly how long it takes. But the holdup is really the editing is going quite well. The technology just gets better and better every year, probably aiming for somewhere between 40 and 50 edits for now. And we've done more than that number of edits already in pigs that are live pigs by nuclear transfer and also in human cells. So I think the editing is going okay. And then we have to do either nuclear transfer into African elephant eggs or grow the embryos in the laboratory, one or the other. That will be probably the most challenging step.
So just to really punctuate how much of a breakthrough this is, what you're talking about is growing a species which has become extinct, which is the woolly mammoth, but it's not exactly a woolly mammoth in an elephant, and it somehow needs to handle the warm weather, because I'd imagine elephants don't like Siberia, but the version of woolly mammoth that you're producing does. Is it even a woolly mammoth? Is it an olifant? Is it a heffalump? Like, what are we talking about here?
So most of the elephants, both ancient and modern, share a lot of DNA. They're essentially hybrids. They're capable of hybridizing, even though they're called separate species. They're probably capable of hybridizing. So this will be a hybrid that hopefully will have some of the advantages of each, including some new advantages, like we're trying to make them resist the herpes viruses, which is probably the main risk of extinction right now. Somewhere between 20 and 80% of newborns are dying from this herpes virus. So we'd like to make them cold resistant, and we are de-extincting. We're restoring the genes that were extinct, so the versions of the genes that were extinct. And we've already restored a few and tested them for their properties. We, being the whole community, have tested them, and the properties look like they're consistent with cold resistance. So one can bring back the incredible diversity, both in time and space. We have almost no limit to where we can get new and or diverse old features and put them into a hybrid that will be compatible with probably both warm and cold temperatures. I mean, the mammoths had to survive over a pretty broad range, and elephants can tolerate modest periods of time at freezing temperatures, but not long winters at minus 40, which is what the mammoths can handle.
Is this the first time that this level of de-extincting has happened? And what are the ethics questions that surround this? I'm sure people are both excited, but I could also see them being concerned. even though the potential here for reversing climate change seems quite huge, and also for de-extincting species that, in our lack of foresight, have not adequately protected to date?
I think most of the concerns are things that we also were concerned about and addressed very early on. Things like, are we ignoring modern species? The answer is no. We're focusing on the Asian elephant, which is going extinct if we don't provide it with some of the features that we're talking about here, like herpes virus resistance and cold resistance, to give them a new home that's far away from human interference. So that's one is what are we doing about modern species? The second one is, will it be lonely or in a zoo? No, it's going to be in Pleistocene Park and beyond. So hopefully whole herds of them, if the first ones look healthy and happy. There are concerns of, can we reverse it? I think with any new technology, you should have a reversal plan in place before you even start. These are not tiny bacteria, viruses, or insects. These are gigantic herbivores, and it's already been demonstrated that you can reverse herbivore introduction. Some invasive species are very difficult to get rid of, like zebra mussels or, water hyacinths, but giant herbivores have been removed from, say, the Galapagos, where you had too many goats. And then there were a few other concerns that I think they're all addressed or addressable.
And is this just to clarify, is this the first time we have de-extincted a species or will have de-extincted a species in this manner or in general?
Well, we're just de-extincting genes, and it's the first time that an organism that depends on the functioning of de-extinct genes will exist. So there are a couple of viruses have been resuscitated, notably the 1918 flu virus. I was not involved in that. What we have now are elephant cells that contain functioning versions of mammoth genes. That already exists, and that's the first, as far as we know.
So what do we call these creatures?
Well, I would call them, Asian elephants adapted for new environments, or you could call them cold-resistant elephants, or you could call them elamoths if you really want to make a new word.
Oh, elamoths! I like
Trademark that. Sell merchandise, George.
Yeah.
Okay, so first of all, we're big fans and we love the concept. I imagine that this could turn into one of the world's longest science experiments because you introduce the first version of elamoths and you hope that they procreate up north and continue to spread and track and can sort of study a whole lot of things. I see you, George, as someone who probably plays 5-dimensional chess and can think through a lot of the different layers.
That phrase is just forever tainted now. Okay, fine.
I don't know why it would be tainted. Anyway, but to go back to my question, George, how do you see this evolving over the next few decades? If really things were to go as successfully as possible, and then to take it another question, where could all this go wrong?
Well, I think the main way it can go wrong is if the permafrost melts and all the carbon dioxide and methane goes up in the air, which is 1,400 gigatons, which would completely dwarf the 9 gigatons per year that we worry about with all human consumption put together. So that would be the worst case scenario. Probably the second worst case scenario is that they don't breed well, which would then lead to the worst case scenario possibly if there's not some other intervention. We're hoping to not depend on slow breeding. There are various ways that we could get them to go more quickly in parallel, but that's very speculative and it's too early to say whether that's going to work. But the best case scenario is that we can parallelize the production and training of baby elephants so that there's tens of thousands of them more or less simultaneously. The gestation period is 22 months, so that's not that long in the scope of things. Our experience has been that many things that look like they're going to take 6 decades, like the lowering the cost of genome sequencing, took more like 6 to 10 years. So I'm not predicting, it's just keeping an open mind how quick these things can move.
Are you interested as well, George, in reintroducing some hybrid version of the auroch or the passenger pigeon or some other extinct species? Is there a lot of opportunity for this moving forward?
I think that, I'm a little more focused on conservation, as is the group that I'm working with, Revive and Restore. for each living species, there's some things that might be done to enhance their ability to return to the wild, if they're not extinct, to enhance the ability of the wild to support them or them to support the wild. I'm a little bit more interested in endangered species than extinct ones, but there's a lot we can do using the diversity of extinct adjacent and cousins that are extinct. The DNA from those cousins can be used to enhance modern species. I think that's a lot of the emphasis. But, if a species goes extinct, we don't just suddenly stop working on it. And some of the ones you mentioned are quite interesting to other people in the project. I'm entirely focused on elephants and mammoth DNA, but there are hundreds of other projects in Revive and Restore that are also noteworthy.
And you're quite lucky that you've chosen a very cold climate because you're able to find mammoths that are frozen that actually still have DNA that hasn't degraded so much that you couldn't actually use it. Whereas some of these other animals I named, I'm not sure if it sounds like it'd be very hard to find a passenger pigeon or thereabouts up in the tundra or taiga or in the northern latitudes. So it seems like all of the momentum is pulling very strongly for mammoths at this time.
Well, no, that's our reasons for doing the mammoth are more related to Nikita's reasons and Sergei Zimov's reasons. It doesn't have to do with the DNA. The DNA for many non-frozen species are available, including passenger pigeon. There's really high-quality DNA available from a whole variety of extinct species that have never been frozen. That's one of the beauties of DNA sequencing, is that DNA lasts for quite a long time. So yes, there's a good DNA sequence from passenger pigeons and many other extinct species.
So, Nikita, you were talking about your adventures, and I'd love to hear a few of them if you have some short stories. But really, we're looking at a park, which is just a drop in the bucket in terms of scale, in terms of geography, and the total size of the tundra. We want to basically refreeze and restore carbon to a vast amount of land. And it also somehow needs to get paid for. And I'd imagine that funding is a key challenge in getting out of the ground. But very simply, how do you scale?
Well, the question is, what can restrain you from scaling up? So the benefit of doing that in such a remote place as Siberia and Russia is that most of the Siberian Russia is unpopulated, and there is very few industry, and there is no farming. And what we do in the Pleistocene Park, so I have 2,000 hectares fenced. I own about 15,000 hectares. But if I would want to extend it even 10 times or much more than that, even without any governmental support or financial support, I will be able to do that, because I will be not stepping on anybody in blister. So no one have any financial interest there. And that's why it's possible to do. So it's pretty much the win-win situation. And even the natives, they don't really get much profits from the land. So they are not holding to this land as much as, in other places of the world, people do. So scaling up, it's easy. So if you have enough animals and you have already established sustainable ecosystem with where you have enough nutrients, where you have enough seeds pool for grasses to grow quickly, then this ecosystem can expand by itself. So, of course, if we want to do it in a reasonable time, we would need to start several other parks in the other places of the planet, of Siberia, maybe in Alaska, maybe in Canada. And there we will be able, and then these parks would eventually grow up to the scale enough to have meaningful impact on the climate. And I think that financially, that's when people will think that it's an important thing to do, I think, and when people understand that it's critical, I think the money for this project will be able to find quickly, both in Russia and outside of Russia. So it's not that expensive to allow animals to breed freely.
Do you find that you have much support from the Russian government? Are they excited about what you're doing? I know there's a lot to look forward to. I think Russia may be one of the potential winners in a climate changed world with the opening of the Arctic and mineral rights and all of the things that come along with it. But I imagine they might be hedging their bets both ways. If it can be prevented, then things like Pleistocene Park seem like something that can earn Russia a fair amount of money, and that would be great. And if not, they're also preparing for a climate change world and adapting in that way too. Is that a fair summation of how you think your region is thinking about this?
So let's say just maybe 10 years ago, no one was, we were just couple crazy Russians doing this thing, and the broad support worldwide and understanding and acknowledgement of what we do was rather low. And I think in the last few years there is a breakthrough, and it's first of all outside of Russia, definitely. So in US, in Europe, there is a lot of media about what we do. But also in Russia, I think in the last 2-3 years, there has been a very substantial shift from pretty much not knowing what we're doing or not caring into kind of big interest, growing interest. So there haven't been anything stated from a political point of view, but the country originally gave us that land and made it tax-free. So it wasn't that Russia was anyhow against our idea. And now when we started to speak publicly how much benefits this could bring to our country recently, and I think kind of the acknowledgement is growing. And, it's just when you're talking to a government, it's not that quickly. In some places, some countries don't believe in the climate change. And in terms of Russia is accepting, actually started to accept the idea that climate change is real just a few years ago. But it's a Russian scientific problem. So the big difference that, for instance, in the US, all scientists say that climate change is real and politics say it's not. And finally, in Russia, it's the other way around. So, so overall,
right. We're going to avoid the Yakov-Smirnov Russian reversal here.
I like the way that you describe it, Nikita. I think there's probably a good deal of ecotourism as well, because we're talking about a park that maybe people, in the same way that they go on a safari, maybe you have humans who want to come up and watch.
I'm dying to go. I wish we could. It's hard to get there. Yeah.
Book your ticket. But with the introduction of large megafauna or anything that dramatically alters an ecosystem, even with the best intentions, that can sometimes come with unforeseen consequences. And so how do you think about some of these risks?
Well, if you use the same term, the worst case scenario, I would clearly, I'm sure that the worst case scenario will be if we do nothing. That's definitely. So how the world is, in which direction we are moving now, if we do nothing, we are doomed. From practical point of view from us, we are introducing big herbivores to the land where they originally were, and we are promoting the vegetation which originally was there before the first human impact. What we say that this wild nature, as you see, you see it as a wild nature, but in reality, it's invasive species out there, and it's invasive ecosystems out there, and ecosystems which give no profits. So I don't really see any big hidden stones. I'm sure that it's possible to create sustainable ecosystem out there. The question is how quickly we can do that. Will we have enough time to have meaningful impact on the climate before the climate change is there? I don't know, it's debatable. But I know that if we will not do anything, we will definitely get in trouble. So,
absolutely. And what I think the Pleistocene Park embodies is that we live in the Anthropocene, and in a way, humans are to some extent responsible for managing nature and must figure out how to do it in the most effective or efficient way. And it brings to mind the reintroduction of wolves into Yellowstone Park as an example, and actually how that dramatically improved the ecosystem and the carbon sequestration potential. And so what I was trying to get at with my questions is how to mitigate the potential risks in some capacity. But I am 100% on board that doing nothing is the worst case scenario. It's almost, I would push back to those who say large-scale carbon removal is a moral hazard. I would argue it's a moral hazard not to start pursuing large-scale carbon removal. But it's more around the how to mitigate the risks. Let's just assume you have all the money you need. You have all the megafauna you want. George's technology works. He's sending you all the, the Elamoths?
Alamoths, yeah.
Yeah, the Alamoths are coming up there. You have them. And then how do you mitigate the potential risks of the project in one way or another?
But how do you define risks? Risk what? The risk that they will all die out, or what's the risk?
I think, Christoph, correct me if I'm wrong, your concern is that somehow we're not able to recreate these grassland environments and instead introduces complexity in a way that maybe backfires or makes things worse. Like what if they knock down the trees and or to some amount and also did not create grassland, something like that?
Sure, as an example.
Well, no. We've been running the Pleistocene Park for 20 years already, and I clearly can state you that the grasses appear. What I learned in the last few years, that we do need some nutrients, that we need some grass seeds, but if we have that and we have animals, the grasses are growing very well. Also, when you're talking about permafrost degradation, permafrost is, let's say, 40 meters. Well, permafrost is in our case, in our region, 600 meters. So down to 600 meters, there is all frozen. But what we care about is top 40 meters. But even those 40 meters, for all these 40 meters to thaw, it will take more than a century probably. And then probably a couple, 2-3 centuries for this carbon to be, at least half of that to be emitted to the atmosphere. And that's a long process, and potentially it can be slowed down and stopped. However, permafrost is not only huge storage of carbon, but in reality, it's also a huge storage of nitrogen. So it's very fertile soil. So there is lots of nutrients in the permafrost. And in case if we will have permafrost degradation eventually, it will be bad for the climate. But in terms of establishing high productive ecosystems, it will be super good, honestly saying. Because when permafrost degrades, all modern ecosystems are getting destroyed automatically. You don't need to have mammoths to knock down a tree. With the climate change, all the modern trees, majority of the modern trees which are growing out there in the region will fall down because the ground will collapse. So it's not, when people say, oh, what you're saying, you're knocking down trees. Well, first of all, I don't knock down trees, but reality that all those trees are doomed. So climate change will not be mild on the large trees because the ground will collapse and fertile soils will appear and immediately the grasses will start to grow. And the reason that by the time that when permafrost will start to degrade, we do need to have lots of animals, so they would be able to come and expand to this land and occupy these new grasslands. And then we will be able to stabilize it. So it's a kind of complex problem. And climate change is the issue, it's a risk. Because sometimes you can have rain events in the winter and ice is forming on the snow and animals cannot trample. Your ecosystem should be big so animals can migrate from less favorable conditions to the more favorable conditions. But at the same time, climate change can also be beneficial in some cases for this ecosystem.
What's next for the both of you? I saw the film rights for Woolly by Ben Mesrich, the book about your story, at least so far, had been bought and they're in development. Is there a movie coming? What else is happening? What should we look forward to in the next little bit of time from you both?
Well, yes, 20th Century Fox has purchased the rights and is moving forward as far as I know. It's important to be able to communicate with a broad set of individuals so that we can, at a minimum, raise consciousness about the possibility of reversal and the importance of the Arctic in particular. So we need more things like that. Just writing a science paper doesn't have quite the impact on the public as a well-told story, especially one that's, in this case, nonfiction, but also non-documentary. So it's kind of the ideal format for getting across this very dramatic challenge and opportunity. What else is a bunch of experiments, both on the ground with Nikita in our lab, trying to do in elephants what we've done with pigs.
Great. That's very exciting. And Nikita, what should we look for from you in the near future?
Well,
besides your sort of like Smokey and the Bandit running cross country with your megafauna in the back, the image of which is amazing.
Yeah, that's pretty much how it's going to look like. Our plans are more or less simple. So we are introducing some of the new animals. Our goal is to allow them to adapt to the new place, extend the park territory, increase number of herbivores. Definitely, then we will need to introduce predators. And I think once we have predators, we will have more or less sustainable ecosystem, which we would want to expand further. And of course, that sounds easy, but reality is always much more complicated, take more time than expected. And of course, yes, we are really much dependent on the financial situation because so far majority of our activity has always been funded from the money we make running the Arctic Research Station in Siberia. And you could guess that fundamental research in Siberia is not the most profitable business of all.
Well, God bless you, Nikita, for trying this. It sounds like you're one of those people doing something that it sounds a little wild at first, but it's one of those ideas that could be hugely impactful and one of those great moonshots. And also, I love ideas like this that have that germ of strong creativity built right into it. I think when people think about climate change, their imagination is oftentimes quite constrained and they're thinking about planting more trees, when really we have to think a lot bigger in some ways, if for no other reason than to get people more excited and thinking creatively about it. Of course, trees are part of the solution as well. Looks like, did you want to say something, Christoph?
No, not really. I was just going to wrap it up. It's rare that we get two such esteemed guests on the podcast who both know each other. And so I was wondering, either for George or Nikita, if there were things that you wanted to ask each other while you were here on the air with us.
That's a fun one, yeah.
Well,
George, you start.
We just spent quite a bit of time together in August, so it is possible to get us in the same room. Also, we sometimes meet. Nikita came to my lab here in Boston, so we've each visited each other's laboratories, and I was certainly not at all disappointed. I was quite impressed, even though I had read many things from their papers on ecosystem. Being there is very moving emotionally, and gives you a great confidence that we can and should go forward. So I guess I don't expect a major update since August. This is hard work. There's no doubt about that.
Yeah, media, well, just social networks and some media, they often demand some, hot news, and everybody wants to hear the hot news. But, both, we do different science, but actually both of this, it's a fundamental science. And, usually it's a very slow process. And there is not that much news coming out. And in terms of what would I want to wish or discuss with George, not much really, but, I understand that some tasks, if you're taking a task which no one have ever done before and no one can write you a book how to do it exactly, it's always going with complications and some failures. And when there are failures, people are, it's often, especially if there is a, social pressure on you at the same time. It's always might be challenging to find motivation to continue doing what you're doing if it doesn't really work from the first time. And so I wish him and myself as well enough, courage and interest to achieve what we are proposing.
If our listeners wanted to keep up with what the both of you are doing or support your work in some way, what's the best way for them to do so?
There are two beautiful websites. One is Nikita's, and the other is Revive and Restore, which is a broad set of species. And Nikita's is specifically on Pleistocene Park and their research station.
Yeah, so we have our website. We have more or less active Facebook page for the Pleistocene Park. And if you would want to support our work, we do have a US registered nonprofit, which is 501c3. It's called Pleistocene Park Foundation. And it's also have its own website, so you can go there and support us through this foundation.
Excellent. Well, thank you both so much for joining us. We want to do this for a long time, and I'm happy that we finally just said we're just going to call these folks up, get them on remotely if we have to. So thanks so much for doing this. Thanks for enduring the technological challenges of podcasting remotely, which have not caught up nearly as much as I might have hoped. And thanks for teaching us, and thanks for inspiring people with what you do.
Yeah, thank you very much. Thanks for interest to our work.
Yeah, thank you all.
Our pleasure. Thank you. And if you like the show, please rate and review us in iTunes, subscribe, tell your friends. It helps a lot and helps us keep doing what we're doing. So thank you so much for listening to Reversing Climate Change.